Thank you for giving me this opportunity. First of all, I would like to thank the organizing committee of the Scholar International Conference on Gynecology, Obstetric and Women's Health. I will explore here a Tunisian experience with the co-segregation and co-occurrence of hypopituitarism in Tunisia Turner Syndrome patients. And we will compare familial cases versus sporadic cases. First, I would like to say that Turner syndrome is a chromosomal condition resulting from partial or complete absence of one of two sex chromosomes, the X chromosome. It affects nearly 1 per 2,500 to 4,000 female births. And typically, the Turner syndrome female phenotype associates dysmorphic syndrome with short stature, fibrism, and visceral abnormalities. It is true that research into Turner syndrome continues to reveal new facets and insights, but many questions remain unanswered. The genetic underpinning of Turner syndrome, the etiology of associated disorders. The initial cohort contains, let's begin by the history, and the initial cohort contained 45 cases of Turner syndrome, which are followed since the 1990. The age range was very extended from 3 months to 44 years. What was striking was the high level of consanguinity in this cohort and the exceptional familial occurrence in 2 families. One of them was the largest in the literature as far as we know. As we all know, Turner syndrome is characterized by the association of short stature which was present in 91% of patients with mean height of about 140 centimeters, characteristic gonadal degenesis, which is characteristic trait of Turner syndrome, and which was present in 70% of cases with 3 ovaries in 30%. Finally, dysmorphic features was evident in 88% of patients. This is the signs of dysmorphic syndrome we can find in Turner syndrome, and patient may revert in some of them are revert in our patients, like short stature evidence, like low posterior hairlines here, like this photo in our patients. Cubitus valgus, which was present in 88%, shortened metacarpal 4, like in this photo, and multiple pigmented nubi, like these 2 girls. Finally, high arched palate was as frequent as other signs. What about now cytogenetic abnormalities in Turner syndrome in our series? And as we can see here, about half of the cases with Turner syndrome present the monosomy of X chromosome 45X karyotype, with one of X chromosome is missing. This means one X chromosome is completely missing, and every cell in the body has only one X chromosome. In 30% of cases, patients have mosaicism, like this photo, and An error may occur in cell division, resulting in some cells having 2 copies of X chromosomes, while others only have 1. Mosaicism also may involve structurally abnormal X chromosome. In fact, in 20% of women, we have this isochromosome, while ring X chromosomes are present in 4.4%, like this diagram. This is the gray spots correspond to the X ring chromosome. The occurrence of Turner syndrome has widely been associated also with several other pathologies as reported in literature, like ORL pathologies, cardiovascular diseases, metabolic abnormalities, obesity, type 2 diabetes, hyperlipidemia, osteoarticular, also liver abnormalities, urorenal tract anomalies, and autoimmune diseases, neurologic also symptoms. But in this topic, we will focus on a paradoxal or unusual association with pathology of pituitary disease. Association, in fact, between Turner syndrome and hypopituitarism is an unusual finding, and only scarce cases have been reported in literature. Pathophysiological mechanisms are still unknown. These are the 8 publications reporting this co-occurrence, and it's worth mentioning that 2 of these 8 publications were issued by our team. The first one in 2016 and then in 2091. The latter one highlights not only the familial occurrence of Turner syndrome, which is already rare, but also the co-segregation between sexual chromosome condition and congenital pituitary deficiency. Let us now move to the historical of this association. In the history, the first family Turner syndrome was reported in aunt and in her niece in 1963. Then 7 cases of Turner syndrome over 3 generations. Mosaicism were published in 1978. Besides 2 sporadic associations also between Turner syndrome and hypopituitarism were reported in 2000, then in 2003. Here are these 2 cases with a variety of karyotype formula and combined hypopituitarism and hypoplasia of pituitary gland in MRI findings. Now, what about the family occurrence of this association, which was the first time reported in 2005 in 2 sisters? Here are the 2 patients, 2 cases with mosaicism karyotype formula and combined hypopituitarism and hypoplasia pituitary. At this time, there wasn't molecular ethiopathogenic background. After a long silence among authors that lasts more than 10 years, our longitudinal investigation of the Turner syndrome revealed as many as 6 cases of Turner syndrome among 2 families, with only 3 patients from the second family. These are the 2 families. The first one with 2 cases which presents only sexual abnormality of Turner syndrome without hypopituitarism, and the second one, and in this topic we will focus on this family with 3 girls which are presented by Turner syndrome phenotype associated with hypopituitarism. So this association, an unusual association. This is the nuclear family harboring the three sisters dotted in red here, affected by this exceptional association. And regarding the fourth sister dotted in yellow here, she only displayed a Turner syndrome phenotype. These family cases were also compared to three other sporadic cases presenting with Turner syndrome without hypopituitarism. So the question here concerns the pathophysiological link between these two pathologies and whether genetic factors has contributed to this association in the three sisters. We can claim that this association draw two facets of the same pathology, and results of this study were published by our team in 2021, and invite you to read this very interesting paper. This question was addressed by taking into consideration of the role of transcription factor involved in the embryological development of pituitary gland. Some of these are involved in early embryological stage. Others intervene later in cellular differentiation of the different type of cells, and finally in mid-mature pituitary gland. So some transcription factors are studied and are involved in non-syndrome of combined pituitary deficiency, like SOX2, PAX6, LHX3 and 4, PROP1, PIT1, TPIT, and SF1, and so on. Now back to our great family. This is the extended pedigree of our exceptional family, and as we can see here, there is a high level of consanguinity, and this multi-generational family harbors many phenotypes other than the co-segregation of Turner syndrome and hypopituitarism, like sterility dotted in green here. Early infancy death in gray, like here, and other systemic disease like Besset disease dotted in orange here. So there is a wide range and heterogeneity of multiple phenotypes associated with Turner syndrome in our family, in our complex family. To highlight these phenotypic characteristics of this exceptional combination, we opted to describe all cases together, familial as well as sporadic, then to make them comparison between them. So the mean age at diagnosis was 17 years, and all patients were referred for delayed puberty or for short stature as known in Turner syndrome, and all patients exhibited a typical phenotype of Turner syndrome as mentioned above. As for the cytogenetic finding, we found, first of all, two cases of X monosomy, one from sporadic cases and other from familial cases, 3 cases with mosaicism without structural alteration in 3 cases. From them, 1 belonged to sporadic cases, 2 cases with mosaicism with structural alteration of chromosome X, and 1 of them presented a ring chromosome. In fact, this one is the 4th sister who presented only chromosomal abnormalities without hypopituitarism. This is the result of the FISH technique for chromosomal analysis, and the yellow dot is the display of the ring chromosome as it's shown in this photo. Now for the hormonal investigation. The hormonal results conclude to growth hormone deficiency in 3 cases of pan-insulin tolerance test, central hypothyroidism in 3 cases attested by low level of thyroxine and concomitantly low level of TSH, and the hypogonadism, but paradoxal central hypogonadism in 3 patients upon low level of estradiol and concomitantly low level of gonadotrophin, because we expected hypogonadism typically present in the Turner syndrome. Finally, corticotrophin deficiency was detected in 2 cases attested by low level of cortisol and concomitantly also a low level of ACTH. The confrontation now between hormonal and chromosomal analysis didn't show any correlation between cytogenetic finding and the occurrence of pituitary deficiency, and it's worth saying that the 4th sister here in Rose column, who carried a ring X, didn't express any hormonal deficiency, thus raising the hypothesis that probably these structural abnormalities which cause the deletion of genetic material may protect from this patient from hormonal deficiency. So we can find here some correlation between structural alteration of chromosome, X chromosomes, and hormonal finding. In addition, corticotrophin deficiency was detected in 2 out of 3 sporadic cases here in blue columns, and in all family of familial cases. This raises the hypothesis of genetic defects in some transcription factors such as PIT1, LHX3, LHX4, and so on, but not PROP1, since the follow-up of the 3 patients during more than 20 years didn't show any signs of corticotropin deficiency. So, to conclude the co-segregation we can postulate that there is a co-segregation with a gene implied in pituitary cell differentiation and development for a deep reading of our cases. We expose here the imagery investigation, which revealed incongruent results that include 2 normal pituitary gland aspects in 2 sporadic cases, as opposite to a 3rd case here, which with an interruption of the pituitary stem, like as we can see here in MRI image. On the other hand, the 3 sisters with Turner syndrome associated with hypopituitarism showed a variety of hypoplastic pituitary, like as we can see here, from empty cell to frank hypoplastic pituitary. While the 4th sister here with only Turner syndrome had a normal pituitary aspect. So the combination of all these hormonal and imagery data in a particular cohort leads us to explore the biomolecular abnormalities of some transcription factors that commonly play a key role in genetic cascade of cell differentiation and proliferation in the anterior pituitary. This is it's worth mentioning that in fact this is a routine examination in our laboratory. Surprisingly, and contrary to what we believed, we identified for the first time in literature a mutation in PROP1 factor, in PROP1 gene in patients who had a very original and unusual association of familial Turner syndrome and congenital hypopituitarism. The three sisters, in fact, were homozygotes for this mutation, and the fourth one having an X-ring chromosome and without hypopituitarism was heterozygotes for the mutation. It's very important to say also that the same mutation was present in other sporadic cases with combined pituitary deficiency, but without sexual chromosome abnormality, suggesting a founder effect of this mutation. These precious and very important results are submitted in a paper, a high high-level scientific paper currently under review, and it will probably be published in a few weeks. This phenotypical and genotypical paradox remain unsolved since PROP1 mutation and usually lead to an almost obligatory corticotrope deficiency, as we can see here, in contrast to PIT1 or LHX3. Which harm corticotrophin cells. So our results underline a dilemma and an extreme heterogeneity as regards of the cytogenetic data on the one hand and the phenotypical expression on the other hand. Indeed, the search for the PROP1 mutation was negative in one sporadic case with such association, unlike the familial cases, accounting for the extreme complexity to establish correlation between phenotype and genotype in our cohort. So to try to explain this discrepancy of the collected results that undermines that the classical knowledge about the pathogenesis of Turner syndrome and highlight the intricacy of the underlying mechanisms and the genomic aspects of Turner syndromes, as shown is this illustration taken from a recently published paper in 2021. In fact, although it was previously believed that Turner syndrome is an X chromosome pathology where the missing X chromosome provides instruction for making protein involved in different roles in the body, a complicated picture of a genotypic effect on phenotypes in Turner syndrome is beginning to emerge with epigenetic changes, alteration in RNA expression, and protein change. Importantly, the mindset in the genomic area have moved away from focusing on single genes on the absence X chromosome, like as we can see here. For each malformation, we have corresponding genes. This will be more large, and we must focus on more subtle changes in the genome, epigenome, and transcriptome to explain the phenotypic changes in Turner syndrome. Our innovative results will probably complete these pictures with a gene interaction. As we can see here, there is a crosstalk always between autosome chromosome and sexual chromosome, and the change between controls between X chromosome and transcription factors may lead to this heterogeneity in expression of Turner phenotype. So to summarize, it's important to highlight that the association between Turner syndrome and hypopituitarism is an unusual finding, and scarce cases are reported in literature, and pathophysiological mechanisms are still unknown. This co-segregation between two congenital pathologies whose etiopathogenetic links still remain to be clarified. This co-segregation also has raised an exciting hypothesis with postulates that there is an interrelation between transcription factors and segregation abnormalities of sex chromosomes could be responsible for a cascade of endocrine pituitary damage, and the causal link between the two pathologies could in the future upset the understanding of the pathophysiological mechanisms of growth retardation, for example, in the context of Turner syndrome, which classically attributed to a resistance for growth hormone, or also structural abnormalities of the X chromosome. Thank you for your attention, and